All right, before I show you the problems, this is a quick recap. When you multiply, what direction do you move the decimal? Dog. To the right. What about when you divide?
To the left.
To the left. How do you know how many times to leap? Michael.
How many zeros?
Right, so you're going to count the zeros and then leap accordingly. Just my advice to you, a little word of warning. Make sure that you read the sign, the operation, division, or multiplication right away, because it's mix and match. It's going to jump around. So that is the only thing that I worry about is you know how to leap, you know how to do it. It's just a question of whether you leap in the right direction. So first thing, identify, am I multiplying, am I dividing, and then decide how many leaps and in which direction you're going to leap that decimal. Okay? So I'm going to show you all 5, write the problem, and then just get the answer using the shortcut. Here you go. Emma, what'd you get for number 1? How many got 90.6? Okay, we're multiplying, so we know we're moving the decimals to the right. We've got 1 0. Move the decimal once to the right, and that's how you get 90.6. Alex, what about number 2? Alex Vecchio. How many got point? Would you read it to me? Point, and then give me the digits again. You got it, but you left off the 8. You still need that 8. How many got 0.1218? Okay, division. So now we know we're going to the left. 2 zeros, 2 leaps. Number 3, Antonio.
I got 48.
How many got plain old 48, whole number 48? Okay, let's see. We got how many zeros? 4. 1, 2, 3, 4. 48 point, which is 48 is a whole number. Michael. I would take them out. You don't need them. They're called insignificant zeros. All right. If you left them in there, would I take off credit? No, I wouldn't. Number 4, Max.
175,953.
How many got that? Yep, three zeros, 3 leaps right, and we're good. Aiden, what about number 5?
I got 1005.
Let's see. How many zeros? How many leaps?
2.
Ready, watch, bud. 1, 2. Only requires 1 0 to fill up the empty nest with the egg. So the correct answer is 0.055. Hands up if you got that. Okay? So that's what you're going to expect tomorrow. 20 questions, 5 minutes. Okay? Lesson 18A is all about greatest common factor. Can you raise your hand, especially you, because you're from out of district. Have you done greatest common factor before? Yeah. GCF? Have some experience with it? Let me give you a sneak preview before I give out the packets, just so we know what it is that we're doing. Don't have to write this. If I give you the number 8, give me 2 numbers that go into 8.
2 and
2 times what?
10.
Agree?
Mm-hmm.
Okay. What if I give you 10? Give me 2 numbers that go into 10.
2 and 5.
2 and 5. If I ask you, what is the greatest number that can go into both of those numbers? What would the answer be? What's the greatest number that can go into both? Tyler.
4.
Let's see. Can 2 go into 8?
Yeah.
Can 2 go into 10?
Yeah.
Is there anything higher than 2?
No.
The greatest common factor of 8 and 10 is 2. Okay? Try another one, okay? 15. Give me 2 numbers. 2 numbers for 24. Krista. What's the greatest number that goes into both? Now, this is tricky because, look, we can't see it here. But you got to start thinking, okay, give me a number that goes into both 15 that will also work for 24. Dog.
3.
Will 3 work? Does 3 go into 15?
Yeah.
Even though we don't have 3, 6 breaks down to 2 factors of 3 and 2, and 3 will go into 24. Anything higher? Greatest common factor of those two numbers is 3. Okay? That's the gist of 18A. Okay? There are two different methods in which I'm going to show to you. Because these are, I gave you kind of simple numbers. I'm going to give you ones that are a little bit harder. I'm going to show you how to break it down and how to do it very systematically. So that's going to be the gist of 18, which we're going to hand out right now. All right, everybody go to page 2 to this. I have a nice colored version of it. You have a black and white version of it. I just want you to understand what we mean when we say the word factor. If I have the number 6, and I ask you what number goes into 6, give me one number that goes into 6.
3.
3 will go into 6. That's one of the factors for the number 6. What's another factor? 2. What else, even though it's not listed here? 1 will go into 6. It's a factor.
6.
And 6. Which leads me into what the definition is of a prime number. Prime number is only 1 and itself will go into that number. If there's others, like 6, yeah, 1 and 6 go into it, but so do 2 and 3. This is not a prime number. This is a what? Composite number. Okay? So that's what we mean by factors. There are two different methods we can list the factors for a particular number. This is called the pairs method. Here's how it works. Let's say I have 18. We're going to start off with 1 and itself. So 1 times what makes 18?
18.
Listed in the box. And there's a reason why we start wide and work our way in, and I'll explain to you after we're doing all of the factors. Do you remember back in the first quarter when we did divisibility rules?
Yeah.
You're going to really put them into play during the next 3 or 4 days. You got to know your divisibility rules. What's the rule for 2? What's the rule for 2? Smiley.
The last digit of the 6.
You got it. Or we could say it has to be an even number or 0. So we look at 18. Will 2 work?
Yeah.
Okay. So we know that 2 is definitely a factor. And then you say to yourself, okay, 2 times what makes 18? Krista. 9 will go here. Ready? What's the rule for 3? Who remembers the rule for 3?
Oh.
Tags.
You add up the numbers, the close, and see if it's 3 or different.
You got it. So if you add 1 and 8, what do you get? Will 3 go into 9?
Yeah.
So 3 will work for 18. 3 times what, Mike?
What?
3 times what makes 18?
6.
Will 4 work?
No.
Will 5 work?
No.
We're done. All the factors for 18 are 1, 2, 3, 6, 9, and 18. See how I started wide and worked my way in? When you do that, and you do it right, and everything is done, everything is now listed in numerical order from least to greatest. 1, 2, 3, 6, 9, and 18. So I kind of want you to do that. I want you to start wide and make your way in. But I also want to show you one more other thing. And as a matter of fact, you know there's a little room at the bottom? Let's do 24 together. There should be room at the bottom for you to do this. And we don't have to worry about the boxes, and we don't have to worry about the connective lines. Just give me two numbers starting with 1 times what makes 24.
1 to 24.
Okay, watch what we're going to do. I want you to put it as wide as possible. Why am I asking you to do that?
A lot of numbers within 24.
Sort of, kind of. Nick said, because there's a lot of numbers that will go into 1 and 24. And he's partly right. The truth is that when we do it, we don't know how much space we're going to need. See, if I start too narrow, don't write this. I wind up having to squeeze a whole bunch of numbers in between 1 and 24, and it gets busy and you can't read it. I don't know how much space I'm going to need to fit all the numbers. So I'm going to start really, really wide, and then after I'm done, if there's a big space in the middle, it's okay. Will 2 work? Times what? Plus 2, plus 12. Will 3 work?
Yeah.
Times what, Steve?
8. Hey. Sorry.
Will 4 work?
Yeah.
Times what? Will 5 work?
No.
And we've already done 6, so we're done. See how you have space in the middle? It's okay.
I think I remember doing this.
It's okay to have space in the middle because it's easy for me to still see that you've listed all of the factors from least to greatest. 1, 2, 3, 4, 6, 8, 12, and 24. Okay? So when you do listing factors this way, it's called the pairs method. Everybody say that. Pairs method. Now I'm going to show you something called prime factorization. Did you ever do factor trees in elementary school?
Yeah.
They used to be common in 5th grade, but now they've moved it to 6th, but some teachers still do it. They're actually kind of fun, actually, so let's do that. Flip the page.
Oh yeah, we did this.
I have to tell you, even though this is here, this example, I'm not crazy about it because I don't like circling every number. I'm going to show you the difference. So kind of skip this and look at my example instead, which we'll do here at the bottom. Yeah, Tyler. What? You're breaking them down. It's not difficult, but there's a certain method to it. And the reason why we're doing this is eventually we're going to get to what's called the greatest common factor. And in order to do greatest common factor, you need to know both methods. You have to be able to do prime factorization, but you also have to know how to list factors too. So I want to show you both ways. So here's how it works. Forget about this top part here because I don't like the way that they circle every number. I want you to give me 2 numbers that when multiplied together make 18. Go ahead, Stephen, start it. Okay.
Or 2, 2 9.
Okay, yeah, I was going to say, do not give me 1 in itself. Just give me 2 numbers other than 1 in itself. So you said 2 and 9, and that's fine. Which one, or both, or neither, are prime? Are any of them prime?
No.
Shame on you.
Yeah. 2 is. Yes, it is. 2.
2 is prime, guys. 2 is prime number. If the number is prime, circle it. I wasn't expecting that. You threw me a curveball because a lot of kids know that 2 is prime. Sometimes I do hear that kids want to say 9 is prime because it kind of looks prime, but it's not.
2 does not look.
9 breaks down to what? Times. And both of those are prime, so you circle it. Every time when you break down a number, if you hit a prime number, you circle it. Once all of your numbers have been broken down into prime numbers, you're done with that tree. And we're going to list the factors. 2 times 3 times 3 down below here. And then I'm going to explain what it is that you just did.
Oh, I did.
What you did, who can explain? Jack. Right, but more so is 9 times 2 though. What's so significant about 3 times 3 times 2? What makes that different from 9 times 2? Or for that matter, which we haven't done, 6 times 3. Well, that also makes 18. But what's unique about 2 times 3 times 3? Aiden. No. Antonio? It is broken down into what? They're all prime numbers. See, 9 times 2, yeah, it makes 18, but 9's not prime. 6 times 3, 3 is prime, but 6 is not. You've broken down 18 to its prime factors. Okay, that's what makes these numbers unique. Now, here's what's neat about prime factorization. This is really cool. You ready? I'm going to leave these numbers here, 2, 3, and 3. I'm going to erase this tree, but don't do it on yours. Just leave yours. We said 9 and 2. What other two factors make 18?
6.
Times. Which one is prime, Stephen?
3. 4.
Break down 6.
2 times 3.
What do you notice?
The same thing.
It's the same thing. Which leads me to this. It doesn't matter how you start, you'll always finish the same way when you do prime factorization. You'll always wind up with the same prime factors no matter how you begin. Let's do 41. 41 throws you a curveball. Are there any numbers that go into 41 other than one in itself?
No. Yes.
I can't think of anything. And if you get stuck, go through your divisibility rules. Will 2 work?
No.
No, it's not an even number. Would 3 work?
No.
No, you add up the digits. It's 4 plus 1 is 5. 3 doesn't go into it. The rule for 4, well, you kind of just know. 4 will not go into 41. It'll go into 40. The rule for 5?
No.
Doesn't end in a 5. 5 won't work. 6 won't work because 2 and 3 hasn't worked. Truth is 41 is a prime number. Nothing will go into it. So you circle it because it's prime, and you write the word prime. Done. Let's do 66. 66 is composite, so get us started. There's a couple ways you can do it.
11 times 6.
Do 11 6. Could have done also 22 times what?
33. We know. 3.
22 times 3 would work too. It doesn't matter how you start. You'll still wind up with the same prime factors. Max, which one's prime, if any?
11.
Circle it. Alex, Wicks, break down 6.
2 and 3.
Which one's prime, if not both, if not either?
Oh.
Circle them both. We're done. Prime factors of 66 are 2 times 3 times 11. Note, again, 2 is a prime number, 3 is a prime number, so is 11. So you've broken down 66 to its prime factors. And it would also work the same numbers if you did 22 and 3. I'm not going to actually do it, but if you want to try it out, you'll see it'll work.
So, if you do like the multiplication problem,
It really doesn't. I always like for organization. Smiley asked the question when you list your prime factors at the bottom, does order matter? Truth is, it doesn't. When I like to do it, and maybe you would like to do the same, I like to list them from least to greatest just for organization purposes. Okay? All right, flip. Now we're going to do, which was a little bit of our introduction, is greatest common factor. There's 2 ways you can do it. We could use the pairs method, and I'm also going to show you the factor trees with the prime factorization method. And I'll kind of give you a hint which works better for what. Here, Kirsten, that's for you, 18A. So if you look at the example, the 2 numbers are 44 and 66, which it's already written for you. They use the pair method to list all of the factors for 44. 1, 2, 4, 11, 22, 44. Same for 66. 1 and 66, 2 and 33. And these are all the factors for 66. The GCF, greatest common factor, is what's the largest number that goes into both. 22 is the number that goes into both. Okay, that's using the pairs method. If the numbers are reasonably small, 44, 66, where you don't have to make a big long list, this can work. This is fine. If you get numbers like 8 and 20, 22 and 11. But if you start getting large numbers, 144 and 500, you'll be listing numbers forever. So the other way that you can do it is using prime factorization, which is easier. Before we get to it, let's practice pairs method to find GCF. We already did 18. Just recall it from the first page. What was it? 1, 2, help me out. It was page 2, I believe.
3, 6, 9, 18.
And we did 24, did we not?
Yeah.
1, 2, 3, 4, 6, help,
12.
8, 12,
Yeah.
24. What factors are in common with both? Dog.
1, 2, 3.
1, 2, 3, and 6 are the common factors. What's the greatest common factor?
6.
That is what we're now going to call from here on out GCF. Let's do 36 and 54. New numbers, guys, now, so we don't know how much space we're going to need. Let's start wide. 1 and 36. Will 2 work?
Yes.
Divisibility rules, yes. 2 times what? If you can't do it in your head, just do division off to the side. But 2 times what?
18.
18, that's fine. We'll get to it. Will 3 work?
Yeah.
Yep, because the rule for 3 is add the digits. That makes 9, and so 3 will work because 3 goes into 9. 3 times what?
4.
Will 4 work?
Yes.
Got to kind of know your times tables now. 4 times 9. 5.
No.
6.
Yes.
Okay, ready? This is something new. 6 times 6, right?
Yep.
Only list it once. No numbers repeat when you do pairs method. Okay, 54, I will tell you, you're definitely going to need the room. 2 will work. First person to get 2 times what will get a ticket, because this is a tricky one.
Oh, I don't think that. Oh,
Jack,
27?
very good, come and get a ticket. Everybody forgets that 2 and 27. Come get. About 3. Will 3 work?
Yes.
Yeah, use your divisibility rules. 5 plus 4 is 9. 3 will go into 9. So it's going to be 3 times something. Ticket if you get it. Mogsy. 3 times 18. Good girl. Come up and get. Will 4 work? Now we're into times tables. Will 4 work?
No.
4 will not work. Looks like it might, but it doesn't. What about 5?
No.
6
Yes.
times.
8.
Eh,
9.
thank you. 6 and 9. And even though we still have 7, 7 won't work,
8 won't work.
and 8 won't work. So we're done with that. Okay, what are the common factors? Bella, do it. I got you started. I gave you 1.
2. 3. 4.
No 4 for 54. There's more. There's one before it. What do you see in both? What do you see in both?
Oh, I said 9 before.
Any after 18.
No.
What's the greatest?
18.
GCF is 18. That's using pairs method. If the numbers are small, I would say within, let's say 24. Like the first string. I think you can use pairs method and it's quicker. When you get numbers above 24, the second method I'm going to show you is quicker if you know how to do it. And that's using prime factorization. Let's try it. Here's how it works. Emma, give me 2 for 8. We're going to break it down into trees. Give me 2 for 8. Which one's prime? 2 for 4. Kelly, 2 for 24. Could you say 8 and 3? Could you say 8 and 3? Could you say 12 and 2?
Yes.
Doesn't matter how you start, you'll still finish up the same. Which one's prime, if any? Okay, which one do you want to break down? It doesn't matter. 2 for 4. Prime? Circle them. 2 for 6. 3 prime? Circle it. Okay, the trees are done. Now, here's how to find the GCF. Ready? Give me a number you see in both trees that are circled. A circled number in both trees. Antonio, give it to me.
2.
Does everybody see a 2? You have a 2 here and a 2 here? Ready? This is the most trickiest part. Cross out both 2's that you see, one in each tree, but you only list the factor once.
Oh.
If you see the 2 in both trees, cross out that 2 that you see in common, but only list it once here. But we're still not done yet. Anything else you see common in both trees? Alex. Sorry, any circled number you see. Forget about the non-circled ones. Okay, here's a 2. Here's a 2. Cross them out. List it once. Anything else? See, I got a 2 here still, and I got a non-crossed out 2 here. Cross it out, list it once. Any others? Any others? No, these are all crossed out. There's nothing else in common. Ready? What's 2 times 2 times 2?
6.
Ah,
No. 8. Yeah, 8. I got that right.
don't add them, multiply them. 2 times 2 is 4. 4 times 2 is 8. The GCF is 8.
Oh, I got this now.
Let's practice prime factorization method one more time.
I get it. I like it.
And just going back for a minute. Both of these numbers, it would work if you did the pairs method. Even 24, it might be manageable. But when you get to numbers that are a little bit bigger now, like 32 and 60, factor trees is the better way to go to find GCF. It works easier, I think it does. It's less time, and it's a little bit more fun, I think. Plus, it's just neater. Kirsten, give me 2 numbers. When multiplied together, make 32. 4 and 8 sounds good. Doesn't matter how you start. Okay? Could also do, if you wanted to, 16 times 2. If you wanted to. Neither one of them are prime, so Liam, let's break down 4. Both prime, circle it. Momo, 2 for 8. Be careful, don't add them. 4 times 4 is 16. 4 and 2. Kaylee, 2 for 4. And we're left with a bunch of 2's. Okay, let's do 60. 2 for 60. Max.
20 and 3.
Gonna do it the hard way, that's okay. Could also do 6 and 10. Could also do 12 and 5. You'll still wind up with the same prime factors. 3 is prime. 2 for 20. Dog. 4 and 5. Could also do 10 and 2 if you wanted to. Doesn't matter. Which one's prime? Circle it. 2 for 4. Jack.
2 and 2.
Sounds good. Both prime. We've broken down our numbers into our prime factors. What do you see in both trees? Smiley.
2.
Cross out the 2 2's you see, but only list it. What else? Steven.
Another 2.
I see another 2. Cross it out. Cross it out. List it.
1.
Anything else?
No.
Multiply the 2 numbers together. What do you get?
4.
Believe it or not, even though these numbers look like there's a higher number that will go into both, 4 is the highest number that will go into both 32 and 60. 4 is our GCF. Try the next one on your own. I'll call you up to the board. And then that'll be it for today. Do 45 and 15.